or in this question, was supposed to be coming up with the cathode and anode half reactions and the net cell equation, the net cell equation, and as well the net potential, the amount of electricity that is required for the electrolysis of these cells. Now, what this means is the amount of energy that's going to be required in order for this, the minimum amount of energy required in order for this to work, so that the strongest oxidizing agent is reacting with the strongest reducing agent. Okay, now the first one is a solution of potassium sulfate. So we're going to put down our reactants. And the reactants are potassium ions and sulfate ions. And of course, since these reactants are occurring in solution, we should also put down water as being one of the possible oxidizing agents or reducing agents. Okay, the first thing I'm going to do is write out the cathode half reaction. Now, the cathode half reaction is where reduction occurs, and so I'm going to look on my data book and have a look down for the strongest oxidizing agent. Now, the strongest oxidizing agent will react with the strongest reducing agent, and when I look down and I have a look at my my reactants here, it is true that potassium ion is an oxidizing agent, but it's a very weak oxidizing agent. You'll come across water first, and so water out of these three is the strongest oxidizing agent, and so the reduction of water is actually going to be what's occurring at the cathode. So from your data book, you'll just write out the reduction half reaction of water, and it's 2 moles of water and 2 electrons, and you get hydrogen gas and 2 moles of hydroxide, and the reduction potential for this half reaction is negative 0.83 volts. Okay, so next we write down the anode half reaction. Now at the anode, we're going to expect oxidation. So we look down in our data book, we look down the list of reducing agents and look for the strongest reducing agents. We don't find sulfate on its own anywhere, but we do come across water as being given the choice between the three here. Water is actually the strongest reducing agent. So at the anode, what is oxidized is water. So when you look in your data book, you write down the oxidation half reaction of water, which means you're looking from right to left for the oxidation half reaction. So we'll see 2 waters producing 4 electrons and 4 hydrogen ions and an oxygen gas. And that half reaction has a reduction potential of positive 1.23 volts. All right, next thing for our net reaction, I'm going to add up these 2 half reactions here. Now I have to make sure the electrons lost equals the electron gains, so I have to multiply the upper equation by a factor of 2 here. So I'll get 4 waters plus 2 waters here, that makes 6 waters. I get 2 hydrogen gases, 4 hydrogen ions, 4 hydroxides, and an oxygen. Now I can actually condense this even more and bring together these two ions here. 4 hydrogen ions and 4 hydroxides is going to form 4 molecules of water on the product side. So I can consolidate this equation by actually removing 4 from this side. So my net equation is going to be 2 waters, 2 hydrogens, and an oxygen. Now for the E net is going to be the cathode minus the anode. So it's going to be negative 0.83 minus positive 1.23, and that comes to negative 2.06. Which makes sense. It's a negative value, which electrolytic cells are, and that's the amount of voltage, 2.06 volts, that would be required minimally to get oxidation and reduction to occur at the electrodes of this cell.